Hello, welcome to this video. The purpose of this is just to go over question 4 from this week's discussion since I didn't get to starting this question. Um, so this question wants us to cross out, or the first part of this question anyways, wants us to cross out the lines that cause compile time or runtime errors. So looking at class A, that code looks fine to me, and same thing for class B. But for class C, there's a few things that are wrong. Mainly if you look at the M3 method where it says super.super.x. So this actually is not valid syntax in Java, so that would cause an error. So we're just going to cross that out and pretend that does not exist. And another thing that I noticed with class C is that, um, let's see, here, right here, super.y. So none of the superclasses of C actually have a y instance variable, so this would not compile either. So let's cross that out. And I think that's all that would, that's all the bad things that would happen. Okay, cool. So this question is mainly testing two things. The first of which is dynamic method lookup. And how dynamic method lookup works is that every variable has a dynamic type and a static type. And the static type is what's on the left side of the variable is the type of the variable, and then the dynamic type is the actual type of the object. And what happens when we do dynamic method lookup is we look in the static class for that function, and if that function is in the static class or any of the static classes superclasses, then we will compile. And then at runtime, what happens is that we go into the dynamic class and we will look for that function in the dynamic class. And if it is there, that's great, we run that function. If it's not, then we look into the superclass and we keep on going until we find it. The second thing that this question is testing us on is field lookup. So methods are looked up dynamically or by the dynamic type. Fields are looked up by either their static type, or if they are called within a class, the fields that you have access to are only the fields in the class in which the function is called. And we will see examples of this later on. Okay, cool. So let's just start off with class D, public static void main. Let's see. Let me erase that. Okay, cool. Alright, so our first line of code is creating a BO, or assigning a B, the variable B0 to a static type of A, and the dynamic type is an object of type B. So what that looks like is here, let me just make a table. So static type and dynamic type, and this will just be like the var name or the variable. Actually, here, let me erase that, and I want the variable to be up here, so var. Okay, cool. Alright, so B0, and the static type is A, and the dynamic type is B. Alright, so what happens is that when we print out B0.x, I said that field lookup is looked up by a static type. So we actually look into the static type of B0, which is A, and we look for the x variable, which is 5. So what gets printed out is 5. Alright, next thing we do is we look at B0.m1. So we do dynamics method lookup here. So we look into the static type of B0, which is A, and we look to see if there's an m1 function. And fortunately for us, there is. It is right here. So this compiles fine. And then at runtime, what we do is we go into the dynamic class, which is type B, or class B, and we look for an m1 function. it isn't there, so what we do is we go to its superclass or its parent class for the function m1, and we keep on doing that until we find that function. For us, the m1 class does have the A class does have the m1 function, so what we do is we print out am1 and then an arrow. And then earlier I said that for fields, the only fields you have access to are the fields within the class in which your function is called. Our function is actually being called in class A, so we have access to the x value that we have access to is actually 5, since that's also in class A. So we get 5. Alright, let's do B, or B0.m2. So once again, we do dynamic method lookup. A does have the m2 function, so we compile fine, and then at runtime we go into the m2, or we go into the B class, and because that is the dynamic type, and we look for the m2 function, and it is there, so we actually execute that function. So we say bm2, and then the value is actually 10 because the class that we're in is B, and we have access to that instance variable. The next thing we do is we look for b0.m3. So we go into the static class and we look for the m3 function, and it's not there, so we throw a compile error. Alright, cool. Next thing we do is we create a new variable b1. It has static type B and dynamic type B. So when we say b1.m3, what we do is we actually look into, or we do dynamic method lookup again, and we go into the static class, which is B, and we look for the m3 function. It's there, so that passes our compile check, and at runtime we go into the dynamic type, which is also B, so we run the m3 function in the B class, which prints out bm3, and then we want the super.x. So what's the super of B? It's A, and A.x is 5. Okay, so b1.m4. So once again, we do dynamic method lookup. It passes the compile check because m4 is in the B class. And at runtime, we execute m4 in the B class. So what it does is it prints out bm4, and then points an arrow, and then it calls super.m2. So super.m2 means class A, we go to class A, and then we call the m2 method from there. So we say am2, and then we say this.x. And since we're in the A class currently, the function that's being executed is in the A class. What we want to do is we actually want to print out that. So that's 5. Alright. Cool. Alright, next step. A C0 equals new C. So C0 is static type A and dynamic type C. So we say, when we say C0.m1, we do dynamic method lookup again. And we look at the A class, and there is a m1 method, so that compiles just fine. So when we go to the runtime, or at runtime, we look at the dynamic type of C0, which is C, and we look for the m1 method. Since it's not there, we go to C superclass, which is B, and we look for the m1 method there. And since it's not there either, we go up to the class A, and that has the m1 method. So we print out am1, and then the value that's printed out is x, because the function is being executed is in the A class. Oh, I guess we don't print out x, we print out 5, because x equals 5 in the A class. Alright, so the next thing that we have is we actually have a variable a1, and being created, it is a static type A, and the dynamic type is casted to an A, which is completely valid because C is a subclass of A. And now we say, but the dynamic type of A1 is actually still a C. And then we also create a C2, of class of static type C, and the dynamic type is also a C, because that's what A1 is. And A1's static type or dynamic type is C. So these two lines of code compile fine. What we do next is we say C2.M4. So what is C2.M4? What happens there? Let's see. So C2 is of class C and M4 does live in that class C. So what we do is we pass the compile check, and at runtime we look into the dynamic class, which is C, and we call the M4 method. So here it prints out CM4 and then Y. And then what is the value of Y in this case? Well, Y is X plus 1. Since there's no X in the current class, we go up one level, or we go up to the parent class, and then we say, okay, is there a X variable? And there is, which is 10. So we have access to that, so we say Y is equal to 10 plus 1, which is 11. Alright, next we cast C0 as a C, and then we call .M3, right? Okay, cool. So what happens is when we cast C0 as a, so casting changes the static type of that variable for that particular line. What happens is we look into class C for the M3 function, and it's not there. So what that means is we have to look up to its parent class to see if there is a M3 function, and there is a M3 function in B, so this passes the compile check. And then at runtime, what happens is we go into the dynamic class, which is still C, and we look for the M3 function, which is not there because it was invalid, so we just crossed it out, and now we're assuming that it does not exist. And then what we do is we look up to its parent, which is B, and B actually does have the M3 function. So it prints out BM3, and then it prints out super.x. Well, what's the super of class B? It is A. And what's A.x? That's 5. Alright, cool. And then lastly, we have B0. Well, I guess not lastly, but almost lastly, we have B0.update. So if we look here, B0 is of static class A and dynamic class B. So once again, we do dynamic method lookup, and we look into the A class to see if there is an update method, and there is. So we pass the compiled check fine, and at runtime, we actually execute. We look in class B for the update method, and it's not there. So we look in class A for the update method, and it is there. So it runs this line of code, which basically reassigns X to 99. So this becomes 99. And then finally, when we say B0.M1, we do dynamic method once again, or we do dynamic method lookup once again, right? So we go to B0, where the static class of B0, which is A, and we look for M1. That function is there, so we compile just fine, and at runtime, we go into the dynamic type of B0, which is class B. And since there's no M1 function there, we go up to its parent class, which is class A, and we see, okay, there is an M1 function there. So we run that. And then what is printed out is AM1. And the value of X within class A is now 99, right? And since we're running this function within class A, we print out that value. So it's 99. Okay, cool. So that's the end of this worksheet. I hope you guys thought it was helpful. If you have any questions, please feel free to post in the comments, and I will get back to you as soon as possible.